In Module 2, we looked at some theory behind solving equations. In this module, we'll see how we can solve some simple equations. We'll start off with a very simple example, this one, and then go on to something a little bit more complex. Recall first that we have operations that give rise to equivalent equations, adding the same number to both sides, multiplying both sides by a number different from 0, or replacing one side or the other of an equation by an equal expression. Equivalent equations have the same solution. We also have operations that give rise to non-equivalent equations. In this case, the first equation implies the second equation. We can multiply or divide both sides of the equation by an expression involving the variable, or if we raise both sides of the equation to an equal power, for example, taking the square root or squaring, cubing, things like that. If we have non-equivalent operations, then we need to take a little bit of care to make sure all the solutions are valid. In practice, even though we combine these two types of operations in solving an equation, we usually use the implications arrow to go from one step to another in our solution. Let's have a look at that example then. Here we have our problem, solve for x when 3x plus 10 is equal to x plus 4. It's a very simple equation. We'll go through the solution in exaggerated detail just to make sure everyone knows the procedure. Well, first we can subtract 10 from both sides. So minus 10, and it implies 3x plus 10 minus 10 is equal to x plus 4 minus 10. Well, that's 3x is equal to x minus 6. We can subtract x from both sides. So that implies 3x minus x is equal to x minus 6 minus x. So our x's cancel out on the right-hand side. And so that implies 2x is equal to minus 6. Then we can divide by 2. X equals minus 6 on 2 is equal to minus 3. So that's with exaggerated detail, just to show the process. This in a simpler way. We'd start with our equation. Implies 3x equals x minus 6. Implies 2x equals minus 6. Implies x equals minus 3. So having reviewed the basic process, let's go on and look at some slightly more complicated equations, although these are still fairly simple.